Hey everybody, Mr. Jones here with you. It's been a while since I've made a video, so first off, if you're watching and you're a Unity Read student, miss you guys. Hope you're doing well. But to my current students, Mount Lebanon students, uh, welcome. Let me share the screen here. We're going to get started on our lesson for the day, which is still talking about these rational inequalities. We started talking about these yesterday, and we're just going to do two examples. Should be pretty quick. So we're looking at number 55 here first. And 55, we got x plus 1 over x plus 3 is less than 2. Okay, so we're going to go through the same process that we did for this one that we did in class, right? So we have the top equaling 0, and we have the bottom equaling 0, right? So we want to find those that we could find. In the top equaling 0, that's going to tell me where my x-intercepts are, right? We see that it's a pretty simple equation. X plus 1 equals 0. So that means my x-intercept is going to be at -1, right? And then obviously setting my bottom equal to 0, x plus 3 equals 0. So that means my vertical asymptote is at -3. Okay. And then also what you guys might notice what's different about number 55 here is that it says less than 2. And you might be thinking, oh, Mr. Jones, why didn't you minus the 2 from both sides so that it says equals 0? And we could do that. That would definitely make our rational function a little bit more complex. So actually what we can do here is we're still going to be thinking below, right? Because that's what a less than sign means. We're going to look for our solutions to this inequality. Normally that would be below the x-axis, right? Because that's kind of our reference line of like y equals 0. But here instead, we're going to look below the line of y equals 2. Okay. And we can use that as our reference line here because, again, normally it's 0. But now it's thinking like what x values can we put into this equation so that it's no longer less than 0, but we're wondering what x values would make that in that a fraction less than 2. Okay. So that's our thought process here. So it's going to just be a little bit different. Okay. So we're still going to sketch our graph. And again, we can put in the information that we know, right? So our x-intercept being at -1. So there's our point. And then we have x equals -3 is my vertical asymptote, right? So there's my vertical asymptote, just like that. And then I have it pulled up on Desmos here. So let me go to that. And so there's our graph right there. So what I can do, again, normally we have this x-axis and that's just easy to see, but because we're using a different reference line here. Okay, so when I go to sketch this graph myself, again, I can, so I can go back here, I can go to my line, right? Again, just going back to Desmos, we see that it is, again, my x-intercepts here at -1 like we saw. There's this vertical asymptote here at -3. Okay, so when I go to sketch this myself, we see it's kind of going like that. Okay, then we also have this portion up here that's kind of going like that. Okay, and again, what I kind of want to look for here, right? Because we did see the top portion of this graph, like the bottom portion of this graph is never going to get close to this line of y equals 2, right? But this top portion does kind of cross through here. So if I represented that, like if I drew my reference line here on my graph, it might be something like that, right? And so we have this certain point that's really important to find because that's the point on my top curve here that it is no longer going to be below that line, right? Below the line y equals 2. And Desmos is great, right? Normally we'd use the graphing calculator. We'd have to trace a little bit to find this, but we see the x value here specifically would be -5. So that's going to be really important because that's going to be included in my solution, right? So I have -2. That's going to be that point right there, right? And again, really important that we have that x value of -5 because that is when it kind of switches over and it's no longer below the that y equals 2 line. Okay. I put -2 again, dang it. So we look at this and we are thinking again, what's my solution? Okay. So my solution here, again, so I kind of scan along my line here. Again, so from -infinity all the way over here, it's below that line, right? Below this whole time. And Desmos is actually helpful to see that too, right? So this whole time from -infinity all the way over until -5, it's below that y equals 2 line, right? So when I write my solution, it's going to be -infinity comma, -5, right? Because at -5, it's no longer below. And then again, I have my vertical asymptote here at -3, okay? And then again, once it goes to the right of that vertical asymptote, it's now below again, right? So it's below that line, and then it comes up. And again, I'm not concerned with the x-axis, right? It goes above the x-axis here at -1. But again, I'm not answering that. I'm wondering, when is it going to be below this y=2 line right here? And it's going to be below that for the rest of the time, because my horizontal asymptote here is actually at +1. And so that means that, what do I put for my second part of my solution? I'm going to put union -3, comma, infinity. Okay, because from this vertical asymptote all the way to positive infinity, it's going to continue to be below that y=2 line. Okay, so a little bit different, using that different reference line on the x-axis, but hopefully that makes sense. Okay, now going down to, we got one more problem here, number 69. Okay, so we got this big guy, okay, x squared minus x minus 2 over 4x squared minus 4x plus 3. Okay, so we're looking at this, and we, again, I know some kids are super hesitant about, like, oh, I don't like factoring. And again, you're here on my YouTube channel, so you can watch my tic-tac-toe videos on that if you want. You don't have to. But it is helpful to factor this, because we're going to have to solve these, right, to find when I set my top and bottom equal to 0. To solve these, it is way easier if they are factored, okay? If you do have a graphing calculator with you and you have that quadratic formula program plugged in, you definitely can still find the solutions that way, but I'm just going to factor them just because that's what I'm used to. So the top is, right at the start, the top here is x squared minus x minus 2. And again, you can do the whole tic-tac-toe, the whole, or whatever strategy you use. What ends up happening is it factors into x minus 2 and x plus 1, okay? And then that is going to be equal to 0. Okay, so I drew my line a little bit too close to that. So I've got x minus 2 times x plus 1 equals 0. Okay, and then again, you guys know when I solve this, basically I take my two groups and I set them individually equal to 0, or I can just flip my signs, right? So x equals +2, x equals -1. Those would be my two answers for that. Again, what are those? Those are x-intercepts, right? Okay, so I have my two x-intercepts there. Okay, and again, as you draw this, or as you find those values, you can draw it on your graph. Okay, so +2, I have an x-intercept, and then at -1, I also have an x-intercept. Okay, and then again, bottom equal to 0, same thing. You could factor it. Okay, what it ends up factoring into, you see this minus and this plus right here. Okay, so that's usually an indicator that it's going to be a minus and a minus in their groups, right? And it is. You're thinking, what multiplies to get +3 and adds to get -4? The only thing that can do that is a negative times negative, and it ends up being -3 and -1. Okay. So then we have our groups, right? Same thing. You take each group individually, set them equal to 0, and solve. And you end up getting x is +3, x is +1. And what are those? Those are my vertical asymptotes, right? So again, so I can go to +3, which would be one tick over here. There's a vertical asymptote, and then at +1, there's another vertical asymptote. Okay, there we go. So we're wondering, like, you kind of looking at this like, oh, what's that's gonna look like? So let's go to Desmos. Let's type that in, okay, and see what that's gonna look like. All right, so you see that I typed that in, and again, I typed in the factored version. You could type in the original version too. It's all the same. Okay, but we look at this, and yeah, we see it matches what I had, right? I have my two vertical asymptotes, and you can put those in if you want to. That would be actually x equals 1, x equals 3. So there they are. Okay, we also have my x-intercepts of -1 and +2. But okay, what are we answering here? We are answering, when is this graph? You notice my value there, what it's equal to is 0 again, so that's good. So wondering, when is it just above the x-axis, right? So I'm back to my normal reference line. All right, so I can go in and I can say, okay, when is my graph going to be above that line? Okay, and again, I can also sketch this if I have Desmos here. So again, I see that it's kind of coming up from above here, going down, kind of flattening out near that first vertical asymptote. And then it's coming up from up here, going through there. Yeah, at +2, my other x-intercept, and then comes up here like so. Okay. So there's my graph. A little bit more complicated. Makes sense because we have a more complicated equation. So again, my big question for this is, when is it going to be above the x-axis and for what values? Okay, so again, kind of scanning from left to right. This whole time, from -infinity up until this first x-intercept, it's above, right? Again, I don't include that point because there's no equal to there. But for that first section, I would say -infinity to -1, right? And then I look at my second little curve here, right? Because I got my asymptote. It kind of goes down below here at +1. It's kind of going down forever. And then when it goes to the right of that asymptote, we see that it jumps up here. And now it's above the x-axis again, right? So I could kind of, this whole section right here is above, right? So what would that be? That would be from +1 until, what's this x-intercept right here? That would be at +2, right? So not very long that it's above the x-axis there, but still a little bit. We have to include it. And then it goes below here from 2 to 3, right? And then it's at 3 is my other vertical asymptote here. And then, yeah, once it goes to the right of 3, it's above again. And it's going to be above the x-axis for the rest of the time, right? And we can see that on Desmos too. We have a horizontal asymptote here at 1. So there we go. So what would I say? I would say -infinity to -1, 1 to 2, and 3 to infinity. So 3 sections, 3 different sections of this graph where the line is above the x-axis. Okay, very good, guys. So I hope that makes sense. Again, your homework questions, your 2 homework questions for the day based on that are just the 2 that correspond with that. We've got 56 and 70. Drop my little stylus here. So yeah, those are on the Google Classroom. You guys know where to find those. And let me know if you got questions. All right, guys, very good. See you later.